You've probably spent last year talking to ChatGPT, Claude, and Copilot, and it's been really exciting. You can do a lot of stuff that previously was not being possible. Unfortunately, your management also heard about this little AI thing, and they want it done in your system. They want an AI agent that can understand the customer purchase history and make intelligent recommendation. A system that understands and follow your business rules and can take action on behalf of the user. And as a developer, I look into it and says, oh, wait, this is complicated. This is going to be a nightmare. But today I want to show you a different approach. One where we build complete AI agent from scratch in the time that it takes you to see a single session. Before we dive into the code, let's talk about why this is a complicated problem. When you connect your LLM to your database and code base, you're dealing with several fundamental issues that you're basically skipping over when you do a tutorial. The first thing is the issue of context. The model has some generic idea about the role, but it has no idea about what your application is doing. You have to provide that information to the model. For example, if I go to the model and ask it, how many vacation days do I have? It has no idea how to answer that. I have to be able to find that information, find which API call do I need to call in my system, and then provide that to the model. And a key aspect here is that every time that I go to the model, I have to carry with me the entire history of my conversation. So I ask it about my vacation balance, then I ask it, can I take a vacation next week? Well, it doesn't know because that's a separate call, and I have to carry that state with me each and every time. The other problem is that the model is charging you on a per token basis, which basically means that as the more text you give it, the more text it gets back. Then this is how it charges me. And because we have to carry the entire conversations each time, the longer the conversation goes on, the more complicated things become. Then we have the security problem. We cannot just throw the entire data set into the prompt. I want to ask you about my vacation days, not Andrew's. But even if I tell the model, hey, only answer about this guy and not that guy, well, there is a very clever trick where you ask nicely, and the model will actually do that for you, bypassing all of your bureaucracy and security rules and stuff like that. Prompt injections are real, and they have serious consequences. Oh, you added AI to your system, welcome to a whole new world of security training and the worlds that you have to go through. So that's complicated, but we're not done yet, because there's also the issue of integration complexity. You need a vector search to have semantic queries. You need to store the embedding sample. You need to store the conversation memory. You have to call tools, and all of that needs to work together with your existing code. By the time you're done, you're not actually doing any meaningful business work. You've built a distributed system to answer how many vacation days do I have. It would have been literally easier to go ask HR and do this manually. Here's what we do differently. Instead of treating AI as something that you just add to your system, we built it in as the core concept. Your operational database becomes part of your AI platform. The same data, substitute the model, same transactions, but now you have the ability to invoke AI directly from the database data. This is important because we are also doing that in a way that is state-sensitive. Let me show you what I mean by building a real HR assistant live coding right now.
Let's build an AI agent. We have here a sample database, and you can see that we have some employees. We have things like HR issues, and John Dev is missing some overtime hours. We have stuff like vacation requests, etc. Now we want to take these data sets that we have and expose that in an agentic manner so employees can do all sorts of interesting things, including stuff that we didn't expect them to do using AI. And this sounds like a really big request. It isn't. Let's see how. So the first thing I'm going to do, I'm going to define a simple HR assistant. And this looks like this. And you can see here that there is a system prompt, and this tells the model what it is, what it's supposed to be doing, the context of operation, etc. Here we have the format in which we want to get the results back. This is important because this allows me to operate over data in a programmatic fashion. And now we get to the crux of the matter. Here we have the employee ID. This allows me to define parameters that define the scope of the agent, what it is able to do, what sort of operations are available to it, etc. And for example, you can see that I'm asking for get employees info. And this is the query. This is the RavenDB query that I'm going to execute. This is added to the initial context. So whenever I run this code, it's going to be immediately available to the agent. But we also have stuff like vacations. In this case, give me all of the vacation for this particular employee and things of this nature. Now let's make use of that. And I want to make use of that from code. And you can see how this looks like. Less than 30 lines of code. And the key here is this. This is a conversation. Conversation is similar to an object instance compared to an agent class. This is a particular instance of the agent. You can see that we define here the parameters for this particular agent conversation. Then we just run it on a loop. And this is the simplest possible thing that could possibly work. We read it from the user, we send it to the model, and we get results back. So I'm going to ask a question, and the question is, what is my full name? And it's going to take for a second, and then give me results back. And here's the result, and here's John Dev. And this is the equivalent of a hello world, because this is so small and obvious, but then you realize how much happens behind the scene. Now let's ask a more interesting question. What about my spring vacation? And it's going to figure out that I actually have a spring vacation here. And can I cancel it after the fact? I didn't want, something like that. And now it's going to think about it again. And it is going to use the vacation and leave policy. So this looks like magic. And this is one of the problems with agentic systems. They are super complicated, and yet you have a PhD in math and computer science just to understand what's going on. But it doesn't have to be this way. Let's go back here and try to understand what happened. Here is the record of this conversation. This is the memory that RavenDB keeps about a conversation. It's also super useful to understand exactly what's going on. Here is the prompt that we provided. Here are some parameters that define who we are. And now the first thing that they've done is ask for this. Here is the employee ID, and here is the details. And you can see that here the details are provided to the model. And you can see it's making use of that. When asking about the spring vacations, it is going to execute the get vacation tool, which is just a very simple query. And here are the results. What about when I'm using this thing? This is using the define policy tool. And this is much more interesting, because what you can see here is that this is actually using a vector search query over what's going on. And here is the vacation time. This is the vacation time policy. And now it is able to do this, to give me a concrete answer. Now, this looks silly, but this is actually really impressive, because within the space of a few minutes, we're able to create a model, integrate it into our system, run it from code, etc. We can also do something much more impressive. Here is the full HR assistant. And you can see it has the same prompt. The format that we want has this thing. So what are the likely follow-up questions that the user may have? Same scope, but now we have a lot more tools available to us. We're going to focus right now on the raise issues and the find issues. So let's go back here. Remember that John has an overtime payment issue. And now I'm going to ask a question. This is, by the way, a full application. This is part of the sample applications that you can look at for RavenDB. And what I'm going to ask now is, what about my overtime problem? I wasn't paid. And then it's going to think and ask that. And escalate this, been a while. Okay, it's going to think about it, and then it's going to create this escalation. Let's see what's going on behind the scenes. Here is the escalation. This is a new document. It was just created that reference this. Now it goes to HR and does almost other stuff like that. Let's look at the full conversation that we have from the backend. Here is my overtime problem, and we've seen that. This does a pretty simple search. This is actually really important because let's understand this in detail. What do we have here? We have, this is a query. This is controlled by the LLM. This is scope to the employee. So now we have scope to the employee, scope to the agent, sorry. This is doing a full text search, sorry, not full text search, a vector search, semantic search over this. And here are the results that we have. Then we have this. We are invoking the raise issue call. What's happening here? What's happening here is that the model actually went to my call. So this is the backend of the application that we've just seen. You can see here is the conversation that we are going to execute. And this is the handler for the raise issue. So the model isn't just doing whatever it wants. What actually happened is that it is invoking the raise issue, this code right here. And I get to decide what to do here. I get to run my own business rule, validation, authorization, etc. So this is a much safer mechanism than just trying to glue all of those things together and hope for the best. And now we have a system, this thing that gives me so much power and capability, and I didn't have to sweat bullets to get there. We also have a system that is understandable because we have the entire log of the conversation in the backend, including the full back and forth between the model, which you cannot see here because this is the user-facing stuff. RavenDB make it really easy to build AI agents and do that in a way that is fast, safe, easy, and is also, most importantly, scalable, both in terms of complexity and load. You can start building a very simple HR model, so a very simple HR agent, and add to it over time. And every time that you add a new capability, it's not just add a new capability, but how it integrates with the whole team. This is easy and fast, and it's going to generate amazing results.
Let's zoom out and talk about what this means for your architecture. In a traditional rack setup, you're dealing with the operational database, the vector store, and the need to sync between them. There is the conversation memory, the orchestration service, the model itself, and then there is your application. Each one of them has its own scaling, backup, and security models. Each one of them is probably being run by a different provider. You're building a really complicated distributed system. This is what I do for a living, and that scares me. So with the RavenDB approach, you have a database, and that's it. You have everything in one box, one place to monitor, to operate, same security model across the board. Your operation team doesn't need to learn multiple new technologies and how all of them combine together. You don't have to audit additional connection and providers. But here's what I find the most interesting about this. As a developer, I get to have really fast iterations. I want to add a new capability, I add a query. I want to change the behavior, either write some code and do that directly, or I add any action into the system. Update the prompt, something happen. And all of that happen in a very short feedback cycle. If I want to have complex business logic, I don't have to take it from some program manager that tried something that I, as a human, can barely penetrate. I can write it in simple code. It's easy, it's workable, and I can plug it directly into the system. This HR agent that we just built would typically be a multi-month project for a whole team. We did it in minutes. Most of that is me talking. And most importantly, this is maintainable. This is sustainable. You can give it to a junior dev to start adding to that because there is not a lot of complexity there. Your senior developer can now take that and implement similar functionalities and suddenly you have an explosion of capabilities. Your ops teams can monitor that, can manage everything. This is not different than what they do on a day-to-day basis. If you want to try this yourself, we have a complete example on GitHub with the full HR agent code. It should take you about an hour to go through the code and understand what's going on, maybe an hour or two to adapt it to what you need. We are also going to be at the boot, and we're very happy to see you here. And if you want to talk about more complex scenario, whatever this is, multi-tenant agents, or talking about distributed system or complex workflows, or just show the boot and see what other stuff we can do to make your life easier, we'll be very happy to talk to you. The gap between those who are going to be AI system and those not is widening because there is a huge amount of complexity that you have to deal with. It is not required. You can build smart AI applications without going crazy. And the question is not whatever you're going to build them. You would have to do that. The question is how much money, time, and effort it's going to take. It can be easy, and I'm really looking forward to meeting you at the booth. See you there. Thank you.